So here we are looking at problems 15 through 17 now. This is on page 3, right below the word problems. And we're looking for the law of sines. Now remember, on the test, you're going to be given this formula for law of sines. It'll be given to you. And this is also a good indicator that they want you to use law of sines, as if you see this formula. So if we see it, we know we're going to use it. So let's just figure out how to use it, or maybe we'll remind ourselves, how do we fill in the blanks here? Well, remember that law of sines and law of cosines both work with this idea of pairs of opposites. That there's an angle in a triangle and it has a relationship with the side across from it. So if we look at number 15, we see that angle B is across from that side that is of length 25 meters. Right? And now we know that this problem wants us to solve for BC, so that's kind of our X over here, that side. Well, that side forms a pair of opposites with that angle A. So now that I have my pairs of opposites, I can simply fill in my formula here. So I know that the sine of angle A, which is 40, over the opposite side, which is X, equals the sine of angle B, which is 71, over the opposite side, which is 25. So now that we've set up our formula here, using our pair of opposites, all we need to do is cross multiply and solve. So 25 times the sine of 40 equals X times the sine of 71. All right, so we cross multiply. Great, that's a great start. Well, now we just need to solve, and all we mean by solve is we need to get X alone, remember. So we're trying to get X alone. Well, if we have X times the sine of 71, to get X alone, we divide by the sine of 71. So this cancels out and leaves us with X alone on one side. Now that we've got X alone, all we need to do is plug it into the calculator exactly how we see it. So 25 times the sine of 40 divided by the sine of 71. And let's see if I can zoom in enough for you to see here. That's exactly how I typed it in. However we wrote it is exactly how I typed it in. So 25 sine of 40 divided by sine of 71. And then when I press enter, it's going to give me my answer. And they wanted the side lengths rounded to the nearest tenth. So notice the 10th place is here. It's 1 after the decimal. Well, if we look next door, 9 is greater than 5. So this 9 over here is going to go up to 10. Well, there's going to be a 0 in the 10th place, and 1 is going to move over to add with that 16 and give us 17.0 meters, remembering our units. So BC then is 17.0 meters. Now if we look at 16, we get a really interesting example here. So 16, we see that they want DE. Well, DE is over here. That's our X. And we do, in fact, have that pair of opposites. Right? So 45 goes with X. That angle 45 goes with X. But if we're looking at this other side length, we don't have the angle that would be in the pair of opposites with it. Right? We need that angle E. But the good thing is, we know that the sides, or I'm sorry, the angles of a triangle add up to 180. So we can find this angle E because we have two of the other angles. So we just add these together, 63 plus 45, and we get 108. And then we subtract from 180. So 180 minus 108 is 72. So this angle right here is actually 72. So we went ahead and we found that by subtracting from 180. And now we have our pairs of opposites. We have both of them. And we can find sine. We can find the law of sines. So we're going to set it up. The sine of an angle, so let's start with the sine of 45 over the side that is opposite, over x, equals the sine of 72 over 3.8. And you can see we literally just put sine in front of the angle and then put our pair of opposites together. Right? So we just put sine in front of our angle and put the pair of opposites together. Now we just cross multiply and solve. So x times sine of 72 equals 3.8 times the sine of 45. Well, to find x, or get x alone, we divide by sine of 72. X is alone now, so we're just going to throw that exactly how we see it into our calculator. So 3.8 sine of 45 divided by the sine of 72. And we want it rounded to the nearest tenth, so that's 2.8. Right, and our units were inches, so DE is 2.8 inches. That's our answer. Let's look at one more, just for good measure. So here's 17. They want GH, that's that length over here. Now notice we have this pair of opposites here. And just like the last problem, we have one of those missing angles. Now we could find that angle if we wanted to, but we don't actually need to because we already have this pair of opposites here. I mean, 35 degrees goes with 39 kilometers. So if we're looking at this problem, we can now set up our law of sines. I'm going to do the sine of the angle, sine of 116, over the side that is opposite, so x, equals the sine of another angle, sine of 35, over the opposite, 39. Alright, well we just cross multiply and solve. 39 times the sine of 116 equals x times the sine of 35. Right, now we just want to get x alone. So instead of x times sine 35, to get rid of that sine 35, we divide by sine 35. Right, now x is alone, so we just plug that thing into our calculator. Exactly how we see it, exactly. So 39 sine of 116 divided by the sine of 35. That gives us 61.1. So x is 61.1, and our units were kilometers. So our final answer is going to be 61.1 kilometers.